Good evening, geometry students. I hope everybody's doing well. We are entering into chapter 9, and we are covering multiple sections in this set of notes just because they're not as complicated concepts as, some other chapters. So we're combining sections 1, 2, and 3 in this first set of notes. And what I'd like for you to be able to do by the end of this lesson is to identify, describe, and draw rigid motions in a coordinate plane. So, per usual, we do have some definitions that we need to talk about. What is a transformation? So, a transformation is changing the position size or location of a shape on a graph. So, in other words, you're taking a shape and you're moving it around. Now, in order to kind of distinguish where the shape was versus where the shape will end up being, we have these two words called pre-image and image. A pre-image is the original or the first shape, while the image is the new shape, for lack of a better term. It's where the shape has gone to, basically. Now, there are different types of movements that you can make, but one of the types of movements is called a rigid motion or an isometry. An isometry is when you don't change any properties of that shape. So, when you don't change any properties of the shape. So for example, if you were to slide, let's just do this highlighter right here. If you were to slide this highlighter, I'm not changing any of its properties. Or if I were to spin it, I'm not changing any of its properties. But if all of a sudden I were to put it in a magical shrinking machine and it became very small, that would be changing properties because it would then become it would not be as long, so then its length would have a different value. So that would be an example of changing a value, but if you were to just flip it over like that, or to spin it or move it, that's not changing a property of that shape. So we have a number of types of transformations, and we have them all listed here. So a reflection is when an image is flipped over a line. When an image is flipped over a line. And so if we were to look at this triangle right here as the pre-image, and I'll go ahead and kind of shade that, and I'll make a little note saying shading is equal to pre-image. So here, if we have this guy shaded, then the line of reflection is actually right here. And if we were to take that shape and flip it over like a card or something like that, it would end up being in this new position. We then have something called a translation, not to be confused with the word transformation. Transformation is a collective term combining all of these possible things that you could do to a shape in a coordinate plane, but a translation is specifically when you slide a shape around. So with reflection, you are flipping. With translation, you're sliding. So if this were our pre-image, it slid to the right. And I'll go ahead and do it like that with that one as well. Okay, now we have something called a rotation. And a rotation is when you spin a shape around a point. Now it is important that you identify what point that you're spinning a shape around, because if you're spinning a shape around something that's far away, then its circular motion of rotation is actually going to be a lot wider than if that point is really close. So if this is our pre-image, then this guy kind of spun around like that. Now the next type of transformation that you can do is a dilation, and a dilation is a dilation, but there's kind of two different ways that you can change the size of something. You can either make it larger or you can make it smaller. So if it's larger, then it's called an enlargement. So when a shape is made bigger, but something that you should know is it needs to be by a constant scale factor. So it's being made constantly bigger. So if this were, that would mean that the small image is the pre-image. The small image is where we started, and now this big triangle is the new shape that has taken place because it's an enlargement. Now, if it's a dilation, that's a reduction, then that's going to be when a shape is made smaller. But once again, it's important that we're using a constant ratio. Or scale factor is another way to put that. Ratio, scale factor, kind of used interchangeably. So in this situation, this whole shape, this big guy, would be the pre-image, the great big triangle. And then the image, or the new guy, would actually be this smaller one. So it is important to determine which way you're going with dilations because we want to make sure we're getting that scale factor correct so we know, is something getting bigger or smaller. All right, so now we're going to put this into a little bit of practice just so you can kind of see what that looks like in the coordinate plane. So here we have something called a composition of transformations. And a composition of transformations is just when you do one movement to another after a shape. So when you move a shape multiple times is basically what a composition of transformation is. So when you move the same shape multiple times. So these movements are going to compound on each other, and after we have a new location for that shape, we use that new location to then follow through and do our next movement. So here we're doing congruence transformations, and that means we're not going to change the size of this shape. We're going to do an isometry. So first, it says reflect the L about the x-axis. So right here is our L, okay? And because this is letter A, I'm going to put it on graph A right here. So if you need to draw your pre-image again down here, that's fine. I'll make us a little kind of key again. And I'm going to say that the pencil is the pre-image, and then I will say that the part highlighted in pink, that's going to be the image in these shapes, just so you can kind of see the difference between them. So all I'm going to do first is just copy this image down here onto graph A, so then I can do the letter A isometry on this graph. So that L is on the 2 mark right here. And I need to get a different pencil because it's broken. And it is 1, 2, 3, 4 long. And it's 1, 2, 3, 4, 5 tall. All right, so this is my pre-image right here. I have not performed my reflection yet. Now I want to reflect this across the x-axis. So right here is the x-axis. We know that's the horizontal line. So what we're going to do is take that and flip it over as if it were maybe like a page in a book. So now this corner is 1 unit away from the x-axis. So when I flip it down here, that corner needs to be 1 unit away from the x-axis again. This corner right here is 1 unit away, so I'm going to put it right there. This corner is 1, 2, 3 units away, and it's also lined up with this one. So here's my line of reflection. My original pre-image needs to be the same distance away from my line of reflection as my image is. So if this is 3 away, then this guy down here should be 3 away. This one's 3 away as well. 1, 2, 3. And it's easy to do the corners because then you can just connect the dots like, I don't know, like connect the dots game. So this one is 6 away, so it needs to be here. And now I'm able to connect those to form my L. So now this is the pre-image and this is my new image down here. So the part highlighted in pink is my actual answer for part A. So now I have this as my pre-image for part B, and I'm going to do that. I'm going to do something different to it. So I'm just going to copy this over onto graph B. And so this is looking like this. So now this is my pre-image, and I want to take this, and for step B it says reflect the L about the y-axis. So now instead of flipping it from top to bottom, I'm flipping it from left to right. So I'm reflecting again, and now my line of symmetry, or my line of reflection, sorry, is this y-axis, this vertical line. So now this corner is 2 away, so this one is 2 away. And I'm just taking my points and coordinating them. And then I trace them out. So now this L is reflected yet again, but now it was reflected across a vertical line. So once again, the pink part is my actual answer, because that's what the new movement was. But notice it got compounded. So we started here, and then we went to this, and then we went to this one. But we have a couple more movements we need to do. Now it says translate the L 3 units right and 1 unit up. So I'm going to copy over this shape onto graph C, and like the position of it. So the shape hasn't really changed, just where the shape is on the graph. That's what's changed. Okay. So this is my pre-image. And then our directions are to shift it 3 units to the right and 1 unit up. Okay, so what we can do, we can just look at our corners, and we can just count 3 units right, 1, 2, 3, 1 unit up. So that's where this corner is going to go. And then you do the same for every other corner. So 1, 2, 3, 1 unit up. 1, 2, 3, 1 unit up. And it's okay if they're overlapping. 1, 2, 3, 1 unit up. And this one's 1, 2, 3, 1 unit up. 1, 2, 3, 1 unit up. So now this L has moved 3 units to the right and 1 unit up. It's still the same shape, and I didn't really change the orientation this time. I just changed the location of it. But this guy is my actual image for part C. The last thing I'm going to do is rotate the L 90 degrees clockwise about the origin. Okay, so there's a couple ways that you can think about this. First of all, if it's about the origin, that means that this center part is 1 where kind of like the very center of my circle is. So this guy cannot get any closer to the center or any further away. I need to make sure that however far away this L is from the origin, it stays that far away because the origin is my center of rotation. Now, if it's 90 degrees clockwise, we're really only going to do increments of 90. So 90, 180, 270, or 360 is just going to get you right back to where you went. So if it's clockwise, this guy is going to go in this direction. And let me just go ahead and put this pre-image over here on this graph for us. Just so we easily have it. Okay, so here's our pre-image. Now, a way that you can think about rotations is to literally turn your paper 90 degrees clockwise. So if I'm turning this 90 degrees, now notice where this has ended up. It is on the bottom, it's in the bottom left quadrant. So now I'm reading this as quadrant 1, 2, 3, and 4. So this is my lower left, and I now know, oh, this L, when I turn it 90 degrees, it needs to be down here. So now I just need to, when I turn this paper back, I'm going to put my L in this location. It's going to be on the bottom left side. So it's going to be bottom left side down here. I can also think about it just kind of shifting around, and I know that this base has to stay on that axis. So I've got a point here and a point here, and then this guy's going to be 1, 2, 3, 4, 5 over. All right. So we can check and see, is this L in the same position as it would have been before? So notice bottom left-hand corner and bottom left-hand corner when I draw in that rotation. So this guy is my final location, and this is the image for step D. All right. So that's everything for transformation notes today. We'll continue practicing this in class and then have another notes section with a few more details. But until then, please have a good night.